This video is brought to you by mywayteaching.com.
In this part, we are going to discuss about few problems on the concept of errors, okay, that we studied. So the first problem is the temperature of two bodies measured by a thermometer are T1 is equal to 20 degrees Celsius plus or minus 0.5 degrees Celsius and T2 is equal to 50 degrees Celsius plus or minus 0.5 degrees Celsius. Calculate the temperature difference and the error therein. So we know that the error T dash is given by, or the temperature difference is given by T2 minus T1, isn't it? And in the problem, they have given the value of T2. What is the value? Yes, it is given as 50 degrees Celsius plus or minus 0.5 degree Celsius. Similarly, they have given the value of T1, isn't it? The value of T1 is 20 degrees Celsius plus or minus zero point 0.5 degree Celsius. So, T dash is given by T2 minus T1 and we know the value of T2, that is given by 50 degrees Celsius plus or minus zero point 0.5 degree Celsius minus 20 degrees Celsius plus or minus zero point 0.5 degree Celsius. In case of solving the problems or in case of discussing about the errors, I told you about the errors in difference, isn't it? Which means delta z is given by plus or minus delta A plus or minus delta B in case of difference, okay, error in difference. So here 50 minus 20 degrees Celsius is 30 degrees Celsius. Now this zero point 0.5 is an absolute error and even this zero point 0.5 is an absolute error. So zero point 0.5 this degrees Celsius and zero point 0.5 degrees Celsius, one is delta A and another is delta B. So it becomes how much? Yes, it is plus or minus delta A plus or minus delta B, 1 degree Celsius. Got this? Okay, this is a very simple problem. Let us move to the another problem. So the next problem is the resistance R is equal to V by I. We know it, right? The resistance R is given by V by I. And V is given by 100 plus or minus 5 volt. Okay. And I is given by 10 plus or minus zero point 0.2 volt. Okay. Next, find the percentage error in R. The percentage error in V. What is the percentage error in V? So in order to find the percentage error in R, we should find the percentage error in V and then the percentage error in I. So the percentage error in V is given by 5% and the percentage error in I is given by 2%. Okay, we know that the percentage error is given by the delta A bar by A bar. So this is the mean value or the true value and this is the error value. In the first case and it is multiplied with 100. So in the first case delta A bar, we know that it is 5. The error is 5 and the mean value is 100. So the percentage error is 5%. Similarly, in the second case, the error is zero point 0.2 and true value is 10 and multiply with 100, we get it as 2%. So the percentage error or the we can say the total error in R. The total error in R is given by 7%. Okay, this is the answer. Moving to the next problem. The next problem is two registers of resistance R1 is equal to 100 plus or minus 3 ohm and R2 is equal to 200 plus or minus 4 ohm are connected first in series combination, then in parallel combination. Find the equivalent resistance of the series combination and parallel combination and use the relation R is equal to R1 plus R2 for the first condition, that is A, and use 1 by R dash is equal to 1 by R1 plus 1 by R2 and delta R dash by R dash square is equal to delta R1 by R1 square plus delta R2 by R2 square. Okay, now in the problem they have given the value of what? R1 and R2, isn't it? The value of R1 as well as R2 is given in this problem. So the R1 is given by how much? R1 is given by 100 plus or minus 3 ohm, isn't it? And R2 is given by how much? R2 is given by 200 plus or minus 4 ohm. So in the first case the equivalent resistance R is given by R1 plus or minus R2, isn't it? So R1 is 100 plus or minus 3 and R2 is 200 plus or minus 4. So we already know how to calculate the error in case of addition. So 100 plus 200 is 300 and plus 3 and plus 4 are the absolute errors and it is given by 7 ohm. This is the error in series combination. If we want to calculate the error in parallel combination, then first we should find the equivalent resistance in parallel combination, isn't it? That is asked in the question. So the equivalent resistance in parallel combination is given by R dash is equal to R1 R2 by R1 plus R2. Okay. And here we know the value of R1 and R2 and even R1 plus R2. Just now we solved it, isn't it? So we'll get 100 plus or minus 3, 200 plus or minus 4 and 300 plus or minus 7. So we'll get 200 by 3, that is 66.7 ohm. Then as they have given in the equation, 1 by R dash is equal to 1 by R1 plus 1 by R2, isn't it? So we get delta R dash by R dash square is equal to delta R1 by R1 square plus delta R2 by R2 square. Now we are calculating the value of delta R dash, isn't it? The error in parallel combination. So we can calculate it like this: R dash square into delta R1 by R1 square plus r dash square delta r2 by r2 square. Okay. So delta r dash is given by 66.7 by 100 the whole square into 3, 66.7 by 100 the whole square into 4. So its value is 1.8. So we can write r dash as 66.7 plus or minus 1.8 ohm. Got this? How to calculate the error in series combination and how to calculate the error in parallel combination using the equations that are given in the question. Okay, it is given. We should use this. This is given in the question only, isn't it? And we know the value of r dash, that is, what is this, 66.7. So we should calculate the error equivalent resistance. Okay, that is given by R1 R2 by R1 plus R2 in case of parallel combination, R1 plus R2 in case of series combination. Okay, the equivalent resistance. Moving to the next problem, find the relative error in Z if Z is equal to A raised to 4 B raised to 1 by 3 divided by C into D raised to 3 by 2. So here the relative error is given by delta Z by Z. Relative error in Z is given by delta Z by Z. So 4 into delta A by A plus 1 by 3 delta B by B plus delta C by C plus 3 by 2 delta D by D. Okay, this is the relative error in Z. Relative error in Z is given by delta Z by Z is equal to 4 into delta A by A plus 1 by 3 delta B by B plus delta C by C plus 3 by 2 delta D by D. Okay. Moving to the one more problem. The period of oscillation of a simple pendulum is T is equal to 2 pi root L by G. Measured value of L is 20 centimeter known to 1 mm accuracy and time for 100 oscillations of the pendulum is found to be 90 seconds using a wristwatch of 1 second resolution. What is the accuracy in the determination of G? So we should find the accuracy in determination of G. Or in other words, we should find the percentage error in G. So we know that G is given by 4 pi square by 4 pi square L by t square, isn't it? This is the value of G. And here t is given by t by n and delta t is given by delta t by delta t by n, isn't it? Therefore, delta t by t is equal to delta t by t. Okay. The errors in both L and T are the least count errors. So therefore, are least count errors. So we can write delta G by G is given by delta L by L plus 2 into 4 pi square L by T square. Okay. Delta T by T. So least count errors, delta L is given as zero point 0.1 and L, that is the measured value of L is 20. Okay, plus 2, delta T is given by 1 and it is measured, the pendulum is found to be 90 seconds. Okay, if you simplify this, we'll get 0.027. Thus, the percentage error in G is given by 100 into delta G by G. Okay, that is given by 100 into delta L by L plus 100 into delta T by T. Okay, and we know the value of delta L as 0.1 by 20 and delta T by T is 1 by 90. So after substituting this value, approximately we'll get the percentage error as 3. Okay.